The Earth, for billions of years, was a quiet place. Life existed, yes, but it was predominantly simple. Microscopic organisms held sway in the primordial oceans. Then, something extraordinary happened. Around 541 million years ago, the Cambrian period began. It heralded an unparalleled burst of evolutionary innovation. This event, often called the Cambrian explosion, saw the sudden appearance of most major animal phyla. The seas teemed with new creatures. Life had found the keys to unlock myriad forms and functions. The world was irrevocably changed, a biological Big Bang. Trilobites scuttled across the seabed. Strange creatures like Wiwaxia navigated this new world. The Burgess Shale fossils offer a breathtaking glimpse into this ancient menagerie. Food webs began to take shape, intricate connections between predator and prey. Algae formed the base, converting sunlight into energy. Herbivores grazed upon these early plants of the sea. Carnivores in turn hunted the herbivores. This dynamic interplay spurred further evolution. Defenses evolved: shells, spines, camouflage. Predatory adaptations sharpened, grasping claws, keen senses. The Cambrian seas were not peaceful gardens. They were vibrant, dangerous arenas where the fundamental rules of ecology were being written for the very first time. The invention of predation itself was a profound evolutionary driver. Organisms like Anomalocaris, a giant for its time, patrolled these waters, a top predator in this newly complex world. While the oceans teemed with burgeoning life, the continents of the Cambrian and Ordovician periods presented a starkly different picture. Land was a desolate, hostile frontier. Imagine a world baked by unfiltered solar radiation. Without a substantial ozone layer, the sun's ultraviolet rays bombarded the terrestrial surface with lethal intensity. Any organism daring to venture from the protective cloak of water would face immediate cellular damage. Beyond the threat of radiation, the problem of desiccation loomed large. Water, so abundant in the seas, was a scarce and precious commodity on land. Organisms evolved in an aqueous medium. Their bodies were designed to function in it. Exposed to the air, they would rapidly lose water, their cells shriveling, their life processes grinding to a halt. The challenge of retaining moisture was immense. Early land colonizers would need revolutionary adaptations, waterproof coverings, mechanisms for water uptake from the environment. Gravity, a force largely negated by buoyancy in water, became a crushing reality. Organisms needed structural support to hold themselves up, to move against this constant pull. The climate on these early continents was also a significant deterrent. Without the moderating influence of vast plant cover, temperatures could swing wildly. Water was a sanctuary. Land was a perilous alien desert. The initial conquest of the hostile land was not undertaken by animals, but by humbler life forms, plants, or their ancient precursors. Long before any creature scuttled or crawled out of the water, microbial communities, perhaps cyanobacteria and algae, likely formed crusts on damp rocks near water bodies. These were the true pioneers, eking out an existence in the marginal zones between water and land. They began the slow, arduous process of transforming the barren rock, creating the first tiny pockets of organic matter. The first true plants to make significant inroads onto land were likely small, non-vascular species, akin to modern mosses and liverworts. These plants lacked complex root systems and vascular tissues to transport water and nutrients. They would have been confined to damp environments, hugging the ground near streams, ponds, or areas with frequent rainfall. Their simple structures were nonetheless revolutionary. They developed cuticles, waxy coverings to reduce water loss, and stomata, small pores to regulate gas exchange, crucial adaptations for terrestrial survival. Their presence signaled a profound shift in the planet's biological trajectory, the greening of a previously sterile world. Following the greening of the land by early plants, arthropods arrived. These creatures, already successful in the oceans, had traits pre-adapting them for land. Their chitin exoskeletons offered protection, support, and resistance to desiccation. Early land arthropods were likely small detritivores or herbivores. Fossil trackways hint at these early terrestrial excursions. They were not permanent residents, similar to modern crabs. They faced drying out, harsh sun, and breathing air. Imagine tiny, multi-legged beings scuttling across damp soil. They resembled early myriapods or primitive chelicerates. Their segmented bodies and jointed limbs adapted for land. The success of these early arthropods was transformative. They accelerated soil formation through burrowing and feeding. Section 5, Masters of the Ancient Seas, the great arthropod predators. While some arthropods were making tentative forays onto land, their relatives in the oceans of the Cambrian and Ordovician periods had evolved into formidable giants and apex predators. The famous from the Cambrian, stretching up to a meter in length, was a terrifying hunter. With its large compound eyes, circular mouthparts lined with sharp plates, and two powerful grasping appendages, it dominated the marine food webs. During the Ordovician, another group of arthropods rose to prominence, the Eurypterids, often called sea scorpions. Some of these creatures were truly colossal. Species like, though from a later period, Devonian, had ancestors in the Ordovician and could reach lengths of over 2 meters, making them the largest arthropods ever to have lived. Eurypterids possessed powerful claws and streamlined bodies, well adapted for swimming and hunting. Their imposing presence must have cast a long shadow over the aquatic ecosystems of the time. The dominance of these large arthropod predators in the seas highlights the stark contrast with the nascent terrestrial ecosystems. Section 6, a thin atmosphere, the struggle for breath and survival. Life's expansion onto land during the Cambrian and Ordovician periods was profoundly constrained by the very air itself. The Earth's early atmosphere contained significantly less oxygen than it does today. Estimates vary, but oxygen levels may have been as low as 10 to 15% of current concentrations, or even less during certain intervals. This oxygen crisis had major implications for any organism attempting to live out of water. Respiration, the process of extracting energy from food, is far more efficient with higher oxygen levels. Low oxygen meant that early land animals would have struggled to maintain high metabolic rates. This scarcity of atmospheric oxygen likely limited the size and activity levels of the first terrestrial creatures. The combination of low oxygen and extreme climates created a formidable selective pressure. Only the hardiest, most adaptable organisms could survive and reproduce on land. Section 7, Terrestrial Terrors, the dawn of land-based predation. As plant life and herbivorous arthropods established themselves, however tentatively, on land, a new ecological role began to emerge, that of the terrestrial predator. The first hunters to stalk these primeval landscapes were, unsurprisingly, other arthropods. Equipped with their protective exoskeletons, jointed limbs, and pre-existing predatory adaptations from aquatic ancestors, some groups were well suited to exploit the new food sources available on land. Among the earliest and most fearsome of these land-based predators were giant scorpions and centipede-like myriapods. Fossil evidence, including trackways and body fossils from the Silurian period, immediately following the Ordovician, shows that scorpions were among the first animals to become fully terrestrial. Some of these ancient scorpions could reach impressive sizes, far larger than most of their modern descendants. Armed with powerful pincers and a venomous sting, they would have been formidable hunters, preying on smaller arthropods and perhaps even early small vertebrates if they ventured near the water's edge. The emergence of these terrestrial predators had a significant impact on the evolution of their prey. Just as in the oceans, a terrestrial arms race began. Section 8, Forging the Future. How early hardships shaped life's trajectory. The immense challenges faced by life during the Cambrian and Ordovician periods, the perilous transition to land, the scarcity of oxygen, extreme climates, and the rise of early predators were not mere obstacles. They were crucibles, forging the very trajectory of future evolution. Each hardship acted as a powerful selective force, pruning the tree of life and favoring organisms with novel, resilient adaptations. The survivors of these ancient struggles carried within them the genetic and physiological innovations that would become the building blocks for more complex life forms, including the eventual rise of vertebrates, dinosaurs, and mammals. The development of waterproof cuticles in plants and later amniotic eggs in vertebrates were direct responses to the threat of desiccation. The need for structural support against gravity drove the evolution of robust skeletons, both internal and external. The challenge of breathing air led to the development of lungs and tracheal systems. These were not minor tweaks, they were fundamental re-engineerings of life's basic machinery. Without these early terrestrial pioneers and their hard-won adaptations, the continents might have remained barren for much longer. Section 9. The Unbroken Thread, Life's Enduring Legacy Through Eons. Life before the dinosaurs shows its resilience and drive to adapt. From Cambrian seas to land, life innovated and overcame challenges. Extreme environments acted as an evolutionary filter. Countless forms arose and vanished, but life grew stronger. Cambrian and Ordovician milestones laid the groundwork for all life. Multicellularity, bilateral symmetry, and body plans emerged. Plants and arthropods colonized land, transforming the planet. These interconnected processes shaped evolutionary history. The legacy of these eons is all around and within us.